One of these efforts is being carried out by NASA's Jet Propulsion Laboratory in Pasadena. It's called Project ARES, short for Astronomical Radio Interferometric Earth Surveying. What you're seeing here is the move of the transportable ARES antenna from Palos Verdes, California to Saddle Peak, overlooking Santa Monica Bay, but more importantly, sitting right on the Santa Monica-Malibu Fault. What NASA scientists are doing is looking at subtle changes in the ground which are thought to precede earthquakes. To do this, they are using distant objects known as quasars as a frame of reference.
Quasars are objects that are perhaps at the edge of the universe, and they emit random radio signals. Those random signals arrive at the Earth and are received at a station, ARES, this transportable 30-foot antenna, as well as fixed antennas in the Mojave Desert at Goldstone and at the Owens Valley Radio Observatory. We record the signals then onto digital magnetic tapes, take the tapes after the fact to a special purpose device which matches up the random patterns and then determines the difference of time of arrival. We can determine those differences to within 1/10 of a billionth of a second, and in this way measure with an accuracy now of a few inches the three-dimensional relationship between these antennas, which are separated by many hundreds of miles. And from that we can begin to resolve some fundamental controversies with regard to the size and shape of the Earth, as well as looking for very subtle deformations that are going on in the Earth's crust that may indeed be warnings of future earthquakes.
Before the ARES technique can be broadly accepted by earthquake prediction researchers, its accuracy must be verified. This is being done with the help of the Commerce Department's National Geodetic Survey, who believe the new system could vastly improve traditional land surveying as well.
The Department of Commerce is interested in this type of technology because it could revolutionize the science of land surveying. Not only is it more accurate over longer distances, but indeed it may even be quite a bit cheaper to do it with this type of technology.
This is just a tiny section of the San Andreas Fault that runs through California. Small shifts in the land, either up or down, are measurable and constantly occurring.
Thus, by making a measurement here initially at this site, at this time, and then revisiting this location a year from now or 2 years from now, we will be able to discern those subtle changes in the Earth's crust, which may be indicative of strains accumulating to be relieved later as an earthquake.
While there are still many unknowns, NASA's Project ARES is an attempt to accurately measure slight shifts in the land, a technique that may one day play a key role in predicting earthquakes.